Hey guys, welcome to the notes for Parabolic Parts. We are in Unit 7A. Our essential question is, what are the key characteristics of quadratic functions? So this is our first day in Unit 7, and the first time we're really talking about quadratics in depth. Now the last time we saw quadratics was really in Unit 2. We did learn how to factor in Unit 6, which is going to be a helpful thing for us in Unit 7, so that's why we spent so much time on it. But this is really going to be the first time we see it in depth. So it may look unfamiliar at first, but it is something that you've seen just a while ago. So we're going to review some vocabulary that we did learn in Unit 2, which is what a quadratic function is. So a quadratic function is a non-linear function. And so linear means line. So this function does not create a straight line. It is also a second-degree polynomial. Now it's been a while since we've called it, well, we've talked about degrees. So when we're talking about degrees, that's just really the highest exponent that you see. So if it's a second degree polynomial, then the highest exponent I'm going to see is a 2. If it's a 7th degree polynomial, then the highest exponent I'll see is a 7. If it's a 5th degree polynomial, the highest exponent I see is a 5. But with quadratics, the highest exponent you will see is a 2. Now we did talk about standard form of a quadratic in Unit 6 a little bit, and that is ax squared plus bx plus c. Remember, standard form is you want to go from the highest exponent to the lowest exponent. Now that this is a function, we now have an equation. So it is going to start off as y equals. Kind of like how we had like y equals mx plus b, and then point slope, and all those things where we can graph them and have equations in our calculators. This is very similar. But another way we also say y is by saying f of x. So we can also say f of x equals ax squared plus bx plus c. So remember, y and f of x are the same thing, but they are still, like, they exactly mean the same thing, but one's just in more function notation, whereas y is just in the simple variable form. All right, now let's talk about parabola. Well, what is a parabola? Well, a parabola is just a fancy way to call the U shape that the quadratic makes. So the U shape of a quadratic function. Okay, so I'm going to go ahead and draw two types of quadratics that you will see here. One way you'll see quadratics is if they're facing up like this. So you can have one that opens up. Okay, you could also have one that opens down. So it might look like this. Okay, so you'll have two types of parabolas in Algebra 1. In Algebra 2, you'll have a couple others, but in Algebra 1, your parabolas are either going to face up or they're going to face down. Okay, the next thing we're going to talk about is the vertex, and this is something that we did talk about in Unit 2 as well. So the vertex is also known as the highest or lowest point. It also is kind of like the turning point. And I'll talk about what it means when I'm talking about the turning point. But basically your parabola or your quadratic is going a certain way, and once it hits the vertex, then it turns and it goes the other direction. So let's go ahead and I'm going to copy these pictures. So if you want to go ahead and copy those two graphs into your notes, that would be great. So I'm going to put these here. I'm going to shrink them a little bit. Okay, so with our vertex, you can either have a highest or a lowest point. So here, is there a highest point? No, because it just keeps going up and up forever. But there is a lowest point. So here our vertex would be at the very, very bottom. Okay? Over here we have a highest point, which is going to be at the top. Sometimes we call this the turning point. It's not really referred to that often. I usually call it the highest or lowest. But here, if you think about it, as you're going down, what happens once you hit the vertex? Well, then you start to turn and you go back the other direction. You go up. Here, you're going up, and once you hit the vertex, you turn and go down. So it is also like known as our turning point. Now, those vertex points, or our highest and lowest points, also have a name. So you could have a minimum or a maximum. Okay, so here, the reason why we have a minimum is because there is a very minimum point. There is a lowest point. There is no maximum, though, because that line continues to go up forever. Over here, we have a maximum point. There is the highest point, but there is no minimum. So they're kind of opposites of each other. One's kind of like a trench, and the other one's like a hill, okay? Now, the next vocabulary word is something we've also talked about before, which is the axis of symmetry. Have I used green yet today? Oh, I have. Let's use purple. Axis of symmetry. So I'm going to give you the fancy definition, and then we're going to talk about what that means visually. So the axis of symmetry. Back in like middle school and in elementary school, you guys drew lines of symmetry. So if I gave you a heart and I asked you to draw a line of symmetry, well, you'd be like, oh, well, I would draw a line down the middle like this. Well, why wouldn't you draw a line in the middle this way? Because it doesn't cut it into equal halves, right? So when you're drawing a symmetry line, you want to cut it into equal parts. So the axis of symmetry is the vertical line that goes through, and again, I'm giving you the fancy definition first, that goes through the vertex and cuts our parabola into equal parts. Okay, so I'm going to go ahead and draw a picture of what this looks like. So I'm going to draw a graph real quick. Whoops, let's draw a yellow one. So I'm going to draw an x-axis and a y-axis. Okay, and then I'm just going to draw a quadratic. So it doesn't really matter where your quadratic is. Okay. All right. Now again, the line that cuts through your parabola. So let's talk about where the vertex would be located here. Well, our vertex would be located at the very bottom here. Remember, the vertex is like basically the lowest or the highest point, okay? So here our vertex would be at the very, very bottom. Okay, now the vertical line that goes through our vertex. So the axis of symmetry is going to go through that point because that's the very, very, very center. So if I were to draw a line in half exactly, it's going to go through this. Now, obviously, I drew this by hand, so my line doesn't go through it exactly, but you get the idea. So that purple line cuts my parabola into two parts, and they're both equal on each side. Okay, now, the important thing to remember about this is that it's an equation of a line, okay? So it is a line that goes through our parabola. So now we have to remember how to draw equations of lines. So what axis does this purple line go through? It goes through the x-axis, right? And whatever that number is going to be the equation of our axis of symmetry. So it's always written x equals a number. And that's super important to remember, okay? So for example, like if I had 1, 2, 3, 4, 5, 6 here, right? What number, or the purple line crosses our x-axis at what number? Positive 2. So our axis of symmetry here, or AOS, is the x equals 2. So this is just an example, okay? So you don't have to, it's not always going to be 2, obviously. Your parabola is going to be wherever, but you can draw a line halfway down, and you can think about it crosses through the x-axis, and then you're like, okay, through which number? Okay, moving on, we have a few more vocabulary words that we have talked about before. So the first one is x-intercepts / roots / zeros / solutions. So these all mean the exact same thing. So if I ask you what the zero is, I'm asking you what the x-intercept is. If I'm asking you where the solutions are, I'm asking you where the x-intercepts are. If I'm asking you where the roots are located, I'm asking you where the x-intercepts are located. So these 4 words all mean the exact same thing, x-intercept, okay? So you want to make sure that you've got all of those words down. You don't want to forget any of them. They all mean exactly the same. So an x-intercept is where the function crosses the x-axis. Okay? Now for quadratics, so back when we had lines, let's just think about that. Let's go back to lines real quick, and you don't have to draw this, but if I have a line, let's say I plotted this line, right? How many x-intercepts could a line have? It could only have 1, really. The only way for an x-intercept to have 2 is if it like curved or went back around, but if it curves and goes back around, then it's not a line anymore. Well, with quadratics, you can either have 0, 1, or 2 solutions, or x-intercepts. You can have 0 x-intercepts, 1 x-intercept, or 2 x-intercepts. So I'm going to draw you some pictures of what that might look like on a graph. So One way to have 0 x-intercepts. So let's talk about 0 x-intercepts first. If I don't have any x-intercepts, that means my graph never crosses the x-axis. So your graph could be above the x-axis and open up like this, right? If it's above, then the lowest point it'll get to is right here, and it'll never hit the x-axis. Well, what's another way my parabola would have 0 x-intercepts? If it opened down like this and it never touches the x-axis. So there's 2 different ways that my graph could have 0 x-intercepts. Okay, so those are each a way. Well, what about 1 x-intercept? Okay. Well, 1 x-intercept means it crosses my x-axis only one time. So the only way for that to happen is if our parabola hits the x-axis and bounces back off, meaning that the vertex itself is on the x-axis. So the very, very lowest point, or our vertex here, would be on the x-axis, and that's the only point. How else could you have 1 x-intercept? Well, if it opened the other way, right? If I had the vertex here and it faced the other way. So these are both ways that you could have 1 x-intercept. Well, how could you have 2 x-intercepts? Well, that's if your graph goes to the x-axis 2 times. So you could have a graph that looks like this, and it crosses at these 2 points. Or you can have one that opens down like this, and it crosses 2 times. So again, there's a lot of ways that it can cross the x-axis, but you can either have 0 x-intercepts, 1 x-intercept, or 2 x-intercepts, okay? All right, so then we'll talk about a y-intercept. Now this one is a definition that we've seen before, but an y-intercept is where the function crosses the y-axis. And we've dealt with y-intercepts a lot in all of our lines, like when we're plotting y equals mx plus b and slope-intercept. So you have seen y-intercepts for a very long time. Just a reminder that y-intercepts are 0, number, and that x-intercepts are number, 0. So for an x-intercept, your number is in the x spot. For a y-intercept, the number is in for the y spot. Now, domain and range are 2 things that we haven't talked about in a while. But domain is going to be all possible, do we remember? X values. Domain is always going to be your x values. And your range is all possible y values. Okay? All right, so that's all the vocab that we have so far. I have a ton of space here because I just didn't really know what else to add, but that's just vocab so far. And so now, since this is the first day, we're going to just practice identifying these things as we are looking at graphs of quadratics. All right, so beginning with number 1, I do give you the equation. I'm just giving you that equation just so that you're used to seeing it, but we're not going to be really doing anything with that equation in this lesson. So the equation is going to be here just to show you that, hey, if you wanted to plot this in Desmos or in your calculator, that's what you would type in, but you don't really need it to do today's lesson, but I am just showing it for you. Okay, so let's begin. What is my vertex of this graph? Well, I notice that this graph goes up. Now, there aren't any arrows because we did this with Desmos and it doesn't show arrows, but you're assuming that the parabola continues to go up forever. So the vertex is either the lowest or the highest point. In this case, it is this very bottom point. You also want to think of the vertex as your middle point or your turning point. So I always think about it like, where's the center of my parabola? Well, my vertex is at that very bottom. Now notice the scaling of this. This is 2 and this is 4. So that means that this must be 1, this is 3, this is -1, -1, +1. Okay, so I'm just numbering my number line because this number line doesn't go by ones, right? It's actually going by, well, it does go by ones, but there's halves in there. So you want to make sure that you understand the scaling of this graph. Not every graph goes by ones, okay? All right, so the vertex here would be the point 1, -1. So you would go 1, -1 to get to that point. Okay? All right. The next question is this a maximum or a minimum? Okay, well, do I have a maximum point or a minimum point in this graph? In this graph, I have a minimum point. Okay, I have the lowest point. There is no maximum because it keeps going forever. The next question is asking me is, what's the roots? And it has it in S's because I could have more than one. Well, remember, what's a root? What is a root? A root, again, is an x-intercept. It is where my graph crosses the x-axis. So you have to think, okay, if it's saying roots, then I have to remember, okay, that's x-intercepts. Well, how many times does this graph cross the x-axis? And so mind you that this is the x-axis here. It crosses my x-axis twice. It crosses once here and once at this point. So it crosses at the point 0, 0, and then it crosses at the point 2, 0. Remember, x-intercepts are number, comma, 0. Okay? Well, what's any y-intercepts? Yeah. At 0, 0. And that's going to be 0, comma, number. And that's the y-axis is right here. That's where it crosses. So it crosses in the same spot for the x-intercept and y-intercept at one spot. Okay, and you're only going to ever have one y-intercept. You could have 0, 1, or 2 x-intercepts, but the most you'll ever have for a y-intercept is just 1. Okay, axis of symmetry. Now remember, that's the line that cuts our parabola into 2 parts. So if I want to think about it, it's going to be the line that cuts it in half. And it has to go through this middle point here. So it's going to be this line right here. Okay? So if you want to help yourself out, you can draw a line that cuts it down the middle and be like, okay, that's the line that cuts my parabola exactly into 2 equal parts. Well, what's the equation of this line? Well, remember, what axis does this line go through? It goes through the x-axis. At what number? Positive 1. Remember, the axis of symmetry is always written as x equals a number. So this one was x equals positive 1. So it's whatever the number it crosses through, okay? And I also want to draw your attention to the fact that this number is always going to be the x value of your vertex, okay? Because the axis of symmetry goes through the vertex. So it says x equals 1. Well, in the x value of your vertex, you will also have the same number. All right. Now for domain. Domain is all of our possible x values, okay? Now our domain, if you want to think about it, it's your x-axis, right? So your x-axis goes left to right. So you want to look at this graph. Does it keep going forever to the left? Like, will this just keep going forever and ever to the left? Yes. And it will keep going forever and ever to the right, okay? So if it goes infinitely in both directions, then it can be any single number. So that means domain is all real numbers. So that's how you say infinite amount of numbers in Algebra 1. Now, I do let you shorthand this by saying ARN if you want to. The way that we write it in math language is we write this little R with 2 lines with it, or you can say ARN. Okay? You only have to write one. You don't have to write all of those. But that just means all real numbers. Now, with our range, that's going to be your y-axis, which means you want to go look at the bottom and the top. Does this go forever to the top? Yes, forever and ever it's going to keep going up and up and up. Does it go forever all the way down? No, because it stops here. This is the lowest that it gets, so it doesn't go infinitely low. That means that it's restricted. So we have to name the restriction or show that there is a restriction, that it doesn't go on forever and ever. So here's the trick. So since it is restricted, you will have to write something other than all real numbers. Well, range is what values? Your range is going to be your y values, right? So you're going to start with y, okay? And then you want to think about, does my parabola open up or does it open down? It opens up. So would I put greater than or would I put less than? I'm going to put greater than, okay, because it opens up. So I'm saying that all of my y values are greater than a certain number. So what is the lowest point on this graph? It goes to the very bottom, the lowest y value that it goes to. So you want to look at your y-axis. The lowest it ever goes to is -1. So I'm saying that my y values are all bigger than -1. And here's the trick with this. All you have to remember is that it's either greater than or equal to or less than or equal to. And how you tell that apart is whether it opens up or it opens down. Because it opens up, it's going to be greater than or equal to. And here's another trick. This number right here is always going to be the same as your y value here. So for the axis of symmetry where it says x, it's going to be the same x in your vertex. For your range, it's going to be the same y value as the y value in your vertex. Okay, so that's a trick there to show you. There's lots of tricks to get around these things, but it is a lot of remembering, and you do have to actively practice with it. Okay, Number 2, again, we're given the equation, but we're not going to do much with it. So now we're going to start. What's the vertex here? Remember, that's the turning point or the highest or lowest point. In this case, I have a highest point, which is going to be at the very top here. And it looks like my tick marks are going by 1, so 1, 2, 3, 4, 5. So it's going by ones, okay? So that means that the vertex is at the point -3, 0. So you start at 0, 0, you go left 3, and then you don't go up or down. So that's why you have 0 for the y value. So -3, 0. Is this a max or a minimum? Well, do I have a maximum point or do I have a minimum point here? I have a maximum point, okay, because I have a highest point here. Now it's asking for the x-intercepts. Well, how many times does it cross the x-axis? Just once. It crosses at the point -3, 0. Okay? And then you want to think about your y-intercepts. Where does it cross the y-axis, which is here? Whoops. It crosses the y-axis here, right? And it crosses right at this point down here at 0, -9. Remember, y-intercepts are 0, common number. So this is 0, -9 for my y-intercept. Okay, my axis of symmetry, again, is the line that cuts my parabola into 2 equal parts. So that means it has to go through this middle point here. So I'm going to draw a line, right? That would be our line. Now, you don't have to draw it, but if it helps you to draw it to help you figure it out, that's okay too. So this is the line that cuts my parabola in half. Well, that line, what axis does it go through? It goes through the x-axis. At what number? -3. And remember, this number right here is going to be the same as the x value in your vertex. So those are always going to be the same. So you can always check yourself to make sure those match up. Now our domain here. Well, this parabola is going to go forever to the left and forever to the right. So your domain here is going to be all real numbers. Remember, domain is x values. And here's the trick. With quadratics, if you're just graphing them and there isn't like a real like word problem or anything, and there's no like restriction, then it's always going to be all real numbers. So when we're dealing with this homework and this assignment here, your domain is going to be all real numbers for every problem, okay? Now the ranges are y values, and here we have a restriction because our parabola doesn't go up and down infinitely. It goes down infinitely, but it doesn't go up infinitely. It stops here at the very top and it doesn't keep going up. So we got to say that there is a restriction. Remember, your range is your y values. So you're going to start with the y. Oh, what happened here? Oh, I was hitting undo like a bunch of times, so I got to redo all of that. -3, -3. All right. So let's think about our range here. Ranges are y values. So would it be less than or equal to or greater than or equal to here? It would be less than or equal to here because it opens down. So then you want to think about, well, I'm saying all of my y values are less than a certain number. Well, what's the highest y value? Okay, you want to look at your y-axis here. What's the highest y value that this graph ever gets to? 0. Okay, so the highest that this will ever get to is the number 0. And again, the trick that I told you was that this y value is always going to be the same as the y value in your vertex. Okay, so that's another way to remember that. Moving on to the third example. Again, we're given the equation. First thing we want to look for is the vertex. So here our vertex is going to be located right there, the lowest point there, our middle point. And that is the point, so you want to start, this is 0, 0 up here, so it would be -3, +2. Okay? Now, do I have a minimum point or a maximum point here? I have a minimum point here. I have a lowest point. Now, solutions. Well, what's a solution? Remember, a solution is an x-intercept. So this is my x-axis down here. Does it ever cross the x-axis? No. So if it never crosses the x-axis, then it can't have an x-intercept. So we would say none. You don't want to leave this blank because then it looks like you skipped the problem. So you want to make sure you actually say that there are none. So there aren't any, there are no x-intercepts, or you can just say none. Okay, a y-intercept is where the graph crosses the y-axis. So here is our y-axis. The y-axis is crossed at this point right here. So I see a point there. And that would be the point. Is it going to be 0, 11 or 11, 0 here? It's going to be 0, 11. Okay, y-intercept is always 0, a number. So the y-intercept here is 0, 11. Our axis of symmetry, again, that's the line that cuts the parabola in half, right? It's going to be this imaginary line here. All right, so that's going to go through our x-axis. So axis of symmetry is always x equals a number. Okay. Now, what number does that go through? Well, remember, what's the trick? It's always going to be the same as your x value in your vertex. So those will be x equals -3. And it does. It goes through the point right here at -3. Okay, it goes through my x-axis at the point -3. So I'm just going to draw this line through. All right. Next thing is domain and range. Your domain, again, is going to be all real numbers again. And next, we're going to do our range. Well, our ranges are y values, and there is a restriction with parabolas. It's not going to ever be all real numbers for the range here. So your range here is going to be restricted. So we have y for sure. Now, is it going to be greater than or equal to or less than or equal to? It's going to be greater than or equal to because it opens up. Remember, if it opens up, it's greater than. If it opens down, it's less than. And it is equal to because it is equal to either the biggest point or the smallest. Now you want to look at your y-axis and think about, well, what's the smallest y value that I have, right? Because I'm saying all of my y values are bigger than this one number. All of my y values are bigger than 2. And again, what number is that similar to? Well, the y value in our range is going to be the same y value as our vertex. So that's one way to check yourself. So you don't even really need the graph to be able to figure out the range. All right, and we're down to our last example here. We're going to identify the vertex first. So that is going to be at this point. All right, so that is going to be the point 2, 8. Okay, so again, these are going by ones, right? So 2, +8. Now this has max or min. Do you think this is a maximum point or a minimum point? This one has a maximum point because it has the highest point. There is no lowest point. And then it asks next for zeros. Well, what's a 0? Remember, that's your x-intercepts. So we have 2 x-intercepts this time. It crosses the x-axis at 2 points. So we just list them both. So one of our x-intercepts is going to be -2, 0. Remember, it's number, 0. And the other one is 6, 0. So we have 2 x-intercepts. Do we have any y-intercepts? Well, usually we do. This is the y-axis. It crosses my y-axis one time right here. And that is the point 0, 6. Okay, the axis of symmetry, again, is the line that cuts my parabola in half, so it would be this line right here. Okay, it goes through the x-axis, so it's going to be x equals, and it goes through the x-axis at the number +2. And this number for the x is going to be the same x value as your vertex. Next, we have the range, or domain and range. Domain here is going to be all real numbers. Our range is going to be y is less than or equal to because it opens down, and it's going to be the same number as the y value in our vertex. So you're saying that all of your y values are less than or equal to 8 because 8 is the biggest y value that you have. So you're saying everything else is going to be less than that. All right, so that is it for just identifying parabolic parts. So these are parabolas, and we were just identifying all of their key features. If you have any questions, please feel free to come in for tutoring.